Lesson 8.2.2, Computing and Interpreting Confidence Intervals for the Difference in Two Population Proportions. Introduction. Recall that in Module 7, we considered several polls carried out by the Gallup organization to determine the proportion of adults in the U.S. and other countries who were concerned about the effects of global warming. Imagine that another organization conducted a similar poll in the U.S. for 2 years in a row. The organization found that a smaller proportion of adults in the U.S. were concerned about the effects of global warming in the second year than in the first. The criteria for approximate normality are assumed to be satisfied for each sampling distribution. Try these. In the first time the organization conducted the poll, the proportion of adults in the U.S. concerned about global warming was found to be pi hat is equal to 0.70. I, in this case, think of I as meaning initial. So the initial population proportion was 0.70. In the second poll, the proportion was found to be pf hat equals 0.50. Again, F is being used here for final. So the initial and the final, I and F, okay? First, we will calculate the margin of error for the estimate. Then we will construct a 95% confidence interval for the difference in the population proportions. So the sample sizes for the two polls were NI equals 47 and NF equals 63. Respectively. What is the corresponding value of the estimated standard error of differences, pi hat minus pf hat? So we need to plug everything into this formula, right? So what are we going to plug in? Remember, we have square root here. Pi hat is 0.70 times 1 minus 0.70 divided by the number in that sample, Ni, is 47 according to the problem. And then for Pf hat, we have 0.50, 1 minus 0.50, and then you divide that guy by 63. Okay, because that's how many people were in that sample. What does this equal? I'm going to cut to the calculator so again you guys can see what I enter in and what we get. All right, guys, so this is what I'm going to put in my calculator. So let's go ahead and see what we get here. So I'm going to do second square root, and then I have 0.70 times 1 minus 0.70, close parentheses, divided by 47, plus 0.50 times 1 minus 0.50, close parentheses, divided by 63. When I hit enter here, I get 0.092 after we round to the third decimal places. So we end up with 0.092. Okay, this is the standard error, I should say the estimated standard error, right? Because we're using the sample proportions. So in the table of critical values, find ZC corresponding to our 95% confidence interval. Then use the value you found to compute the margin of error for the estimate pi hat minus pf hat. So remember, guys, if you look at the table from before, ZC is equal to 1.960. You can drop this last zero, it doesn't need to be there, but you can put it in if you want to. So if you want to actually find the margin of error, you just need to multiply that the standard error times the critical Z value. So if I do 1.960 times 0.092, and I put this in my calculator, I end up with 0.180. Okay, 0.180. Okay, so this is our margin of error. Remember what the margin of error is? This is how much we go up and down from our point estimate in order to figure out where the true answer likely sits. Okay, so we are looking at this now. We are going to figure out what both of these things are in this confidence interval so that we can write down the confidence interval. So what is Pi hat minus Pf hat minus E? What is Pi hat minus Pf hat plus E? By the way, some of you might be wondering, how do I know that I subtract them in that order? Is it always initial minus final? The answer is that's actually a good question, okay? There is no standard way of doing this, right? Because some people might want to do the subtraction the other way. So the thing is, you are always going to be told the order of the subtraction by the problem, right? You could see here that they told us the order. Here they told us the order. Right? They will always tell you what order to use for the subtraction. Okay? So that's important, right? Because otherwise, you get the negative answer. Now, that doesn't mean that the answer is wrong. It still means the same thing, right? This is equivalent to if you stand next to somebody who's taller than you, then, if you ask a question, how much taller is the taller person than the shorter person, you're going to get a positive answer. But if you say how much taller is the shorter person than the taller person, of course, it's negative, right? Or another way to say this is, if Bill is taller than Frank, that's the same thing as saying Frank is shorter than Bill, right? So this is why you get a negative answer versus a positive answer. But it's not wrong, it's just in how you interpret your answer. Okay. All right, so let's move on then. What is Pi hat minus Pf hat? We haven't figured this out yet, but Pi hat is 0.70 and Pf hat is 0.50. Okay, so we have 0. Oops, let's undo that. We have 0.70 minus 0.50 minus the margin of error. And then we have 0.70 minus 0.50 plus the margin of error. Okay. So what do we get if we subtract those? 0.2 minus 0.18 is 0.02. And then 0.2 plus 0.18. And we work that out, we get 0.38. Okay? So our confidence interval then is 0.02 until 0.38. This is our 95% confidence interval. Okay, so let's keep going here. Now we will consider how the confidence level affects the margin of error. You may already have an idea about how the confidence level affects the margin of error. What effect do you think increasing the confidence level will have on the margin of error? Okay, you may think that having more confidence in a confidence interval is always better, but then why wouldn't we just go for 100% confidence if that were true? The problem is, the more confident you want to be that your interval captures the real answer, the wider you have to make it. In other words, the more imprecise it gets. Another way to remember this is that when you increase your confidence level, remember your ZC gets bigger, right? And we talked about this in the last module. So increasing the confidence level increases the margin of error, which is bad. So there's a trade-off, right? This is why we can't get too confident, because the more and more confident we get, the less precise we're going to know where our answer sits, right? Because we're talking about a wider and wider thing, okay? So test your idea by increasing the confidence level for the difference in population proportions in question 1 to 99%. 99%, okay? So we want more confidence now. So the number of standard errors allowed at this level is the critical z-score of 2.576. Remember, this is from our table. What is the margin of error at the 99% confidence level? So remember, we need to take the critical z-score and multiply it by the standard error. So what do we get when we multiply these? We're going to get, it's 2.576, and then we're going to multiply it by, let me remind you guys of what that is. That's 0.092, right? That's what we're going to multiply it by. So if we multiply those in our calculator, we end up with 0.237. Is the margin of error at the 99% confidence level from question 2A larger or smaller than the margin of error at the 95% confidence level from question 1B? Well, if this guy is 0.237, let's compare it, right? What was it before? Before it was 0.180. 0.180. So it is larger, right? As we predicted, right? So margin of error with 99% confidence is larger. Okay. So let's look at part D. Complete the following statement. Raising the confidence level makes the margin of error larger. Okay. Complete the following statement. Lowering the confidence level makes the margin of error, of course, it's going to have the opposite effect, right? Smaller. Okay. Again, life is about trade-offs, and in statistics, it is no different, right? So we want to set the confidence high enough that we feel sure about our answer, but low enough so that our accuracy is better, right? So you want to sort of find a number that you are happy with, no lower than that, but also no higher than that. Now we will demonstrate the effect of changing the sample sizes. Let's suppose the sample sizes were quadrupled. For the first poll in question 1 above, the sample size was Ni equals 188, and for the second sample poll, the sample size was 252. So the numbers were quadrupled, all right? So now we're going to figure out what is the new value of the estimated standard error of differences Pi hat minus Pf hat. So let's take a look at the standard error, right? We're going to put in the same Pi hat and Pf hat from before. Remember, those were 0.70 times 1 minus 0.70, except now the sample size for the first one is 188 plus. And for the second one, we have 0.50 times 1 minus 0.50, and that's going to be divided by 252. Okay. So what does that approximately equal? We're going to put this in our calculator, and again, I want to cut to the calculator calculation so you can see how to put this in. Okay, let's go ahead and see what we get for this calculator answer. So we have second square root, and I put in 0.70 times 1 minus 0.70 divided by 188 plus, and then 0.50 times 1 minus 0.50, close parentheses, divided by 252. And then you hit enter, you get 0.046. So we get 0.046. Okay? So this is what has happened to our standard error, and you can already guess what this effect is going to have on the final answer. Okay, so let's keep going. What is the corresponding margin of error at the 95% confidence level? Remember, the critical z-value for 95% hasn't changed, so we still have 1.960, but now we're multiplying it by 0.046. For those of you that remember, last time we found the 95% confidence interval, we were multiplying it by 0.092, so the number is smaller. What do you think is going to happen? We're going to end up getting a smaller answer, so let's see. If I multiply those two numbers, I end up with 0.090. 0.090. Is the new margin of error from question 3b smaller or larger than the margin of error computed in question 1b at the same 95% confidence level? Well, look at 0.090, and the margin of error that we got in question 1b is 0.180. 0.180, so 0.180. And of course, 0.090 is smaller, right? So with the larger samples, the margin of error got smaller. And now they want us to find the 95% confidence level for this new value. So remember, it's going to be pi hat minus pf hat minus the margin of error, and it's going to be pi hat minus pf hat plus the margin of error. What do you get? So this is going to be 0.20 minus 0.090, which is 0.11. And if you do 0.20 plus 0.090, we get 0.29. And so the 95% confidence interval is 0.11 to 0.29. So please compare these. We're going from 0.11 to 0.29 now. And what we had before with the smaller sample size is from 0.02 to 0.38. 0.02 to 0.38. So let's complete the following sentence. Increasing the sample size has the effect of shrinking the margin of error, right? Or reducing or decreasing the margin of error. So when you make the sample size bigger, you decrease the margin of error. Notice that this is a good thing, right? Because we didn't change the confidence at all. We're talking about having the same confidence. So complete the following sentence. Decreasing the sample size has the effect of, if you make the sample size smaller, you're going to increase the margin of error. Okay, so I'm hoping that we're getting to the point here that you guys are starting to understand that if you want to get a more precise, smaller margin of error, you do not want to sacrifice lower confidence to achieve it. Instead, you want to use a bigger sample size, right? That's what we're getting at here. So you could have selected many different possible pairs of random samples and the corresponding proportions pi hat and pf hat. What proportion of the resulting 95% confidence intervals would actually contain the difference in population proportions? So again, 95% confidence interval means that 95% of the time, our confidence interval is going to contain the real answer. So 95% of all confidence intervals constructed would contain pi minus pf. Okay? Look at the values in the 95% confidence interval for pi minus pf. Are the values positive, negative, or both? And use this information to determine which of the following statements is suggested by the confidence interval. Okay, guys, so this has to do with interpretation. When you have a difference, what we really care about when we're looking at a difference is which one is larger. Now look, I know maybe some people might be looking at this problem and saying, wait a minute, why do we have to do any of this? Because clearly it seems like the initial is larger than the final, but remember, these are just samples. What we're trying to do is figure out if the real answers, if these are far enough apart that the real answers are nearly certain to be far apart either. Because remember, it could be just due to sampling variability, right? Okay, so let's think about this, right? If we look at the confidence interval, we get from point 11 to point 29. Notice that this is positive the entire time. Okay, positive the entire time. If they were both negative numbers, we would say that it's negative the entire time. And if one was negative and the number on the right was positive, then we would say that it has both signs, right? But whenever you get one sign the entire time, this is a good thing, right? It means that we're sure what the sign of the number is. Okay? So the values are all positive in the confidence interval, right? Because look, the first question it asks is, are the values positive, negative, or both? The values are all positive. And then it says, use this information to determine which of the following statements is suggested by the confidence interval. So now we have to think a little bit, okay? If you take two numbers and you subtract them, and this gives you a positive number, what does that mean? Which one's larger? Right? I mean, we know that if you subtract two numbers and you get a positive number, it must mean that the first number is larger than the second number, right? So it means you must have this. Okay? If they were negative all the time, we would have had the less than sign. And so this is if you and you would get, what about equal? You get equal when it goes from negative to positive, because then that means 0 is a possibility. And remember, the only way that two things subtract to equal 0 is if they're equal. Okay? All right, so let's keep going here. Does the confidence interval constructed in question 3D allow the population proportions of U.S. adults concerned about global warming to be unchanged over the 2 consecutive years? So if something is unchanged, right, then that means we're talking about these 2 guys being equal. And 2 things can only be equal if their difference is 0. So the answer is no, they cannot be equal because 0 is not contained in the confidence interval. Okay, the only way 0 can be in the middle of a range of numbers is if it goes from negative to positive, right? And it's positive the entire time. Okay. Let's answer the last question. It says, interpret the confidence interval in the context of the global warming problem. Explain your interpretation and be sure to explain how much concern about the effects of global warming has changed. Okay, it says interpret the confidence interval. So we're going to use the last one that we got, which was with 4 times the sample sizes, okay? So let me write down again the confidence interval so that we can interpret it into a sentence, okay? So we had a confidence interval from 0.11 to 0.29. So we are 95% confident that the proportion let me make sure that I don't say this wrong. It says, imagine that another organism, okay, so we're talking about in the US, and it just says 2 years in a row, and it doesn't really tell us what year we're talking about, so let's just call it year 1 and year 2. So, or we are 95% confident that the proportion of US citizens who are concerned about global warming it's gotten bigger, hasn't it? Okay? Because, oh, sorry about that. So sorry, I said that wrong. Yes, actually, I said that wrong, right? If the initial minus the final is positive, then that means, remember, the first number is bigger. So this means that it's actually gotten smaller. So we are 95% confident that the proportion of U.S. citizens who are concerned about global warming has decreased between 0.11 and 0.29. Okay, so that's how much it has decreased by. Or another way you could say it is the difference has decreased between from, well, let me write the sentence from 1 year to the next. Okay, so what we're saying is that it has decreased between 0.11 and 0.29 from one year to the next. Or we could say the difference of proportions from year 1 and year 2 is between 0.11 and 0.29. Okay, so again, you could say how much something has changed by, or you can talk about, the difference, right? I can either say Bill is 2 inches taller than Frank, or I can say the difference in their heights is 2 inches, right? That it's just a different way of saying the same thing. But this is how I would say it, given the way that they asked the question. If the answers were negative the entire time, then that would mean that we would say that it increased, right? So it all depends on how the problem is asked. Okay, everybody, that is it for this section. The code word is global. Again, the code word is global for your submission. Thank you very much for watching this video. I hope it was helpful.